Hello everybody. So far we've looked at quadratic equations and how to solve them. In this video we're going to have a look at quadratic inequalities. And inequalities are just different kinds of relationships. So here's the general quadratic equation, ax squared plus bx plus c equals 0. If you can imagine, instead of the equal sign I had a less than sign, or a less than or equal to sign, or a greater than sign, or a greater than or equal to sign. These sorts of things are the inequalities. So we're going to have a look at solving those. And although it's not directly required in the course for you to know them, in fact, sort of in the background, you need to know how to do these quadratic inequalities for a part of the functions course. So that's why it's worth having a look at now. And speaking of functions, there's no two ways about it. You need to know a little bit about function sketching in order to solve quadratic inequalities easily. So I'll go through that. It's really quite straightforward though, I think. So we're going to do two things, or four steps really, to solve a quadratic inequality. Step one, we are going to well, I'll just put the words down, but it'll make sense once I go through it. We're going to do a thing called determine concavity. And that means that if we have a look at the quadratic function, we can see very quickly whether it's going to be a smiley graph, which is concave up, or a frowny graph, which is concave down. So we're going to determine the concavity. Step two is we're going to find the zeros. And if you remember, finding zeros simply means working out the solutions for x, because they are also the x-intercepts or zeros of the graph. In step three, we are then going to sketch a graph. And we don't need to know the turning point or anything like that, or even the y-intercept. So it's just a very quick sketch of the graph. And again, we'll look at it in more detail in the functions unit. So it's just a brief foray into that. And step four is use the graph to answer the question. And I reckon when we go through the theory, so we'll go through an example, you'll see that. And I'm going to go through three examples now, so I'll zoom out so it's there. And let's have a look at slide 20 here for the first inequality. So what this inequality means is we want to find all values of x. It's not just going to be 2 this time, it's going to be a range of values, all values of x, such that this expression is less than 0. So what we do is we go through each of the steps there. And what we're going to do is we're going to sketch this function here, y equals x squared plus 6x plus 5, just a partial sketch, I suppose. And the first thing to do to work out the concavity is to have a look at the signage of the squared value. If it's positive, so if a is positive, then it's a smiley graph. If a is negative, then it's a frowny graph. And you might remember from the last video, and feel free to go back and watch it, when I was doing the Desmos stuff, you'll note that when I made a negative, the graph flipped over. It doesn't change anything else, the sign of a, it just flips the graph from smiley to frowny, or it changes the concavity of the graph. So with y equals x squared plus 6x plus 5, the value of a is 1. The x squared term is positive, and so we can say that it is concave up, and just putting a smiley there would be enough. Okay, step 2 is to work out the zeros. So we simply set x squared plus 6x plus 5 equal to 0 and solve. Now, you need to go through the usual steps. Is it a difference of 2 squares? No. Is it a perfect square? No. Are there common factors? No. Is it a trinomial that can be easily factorized? Yes, it is. And again, I'm just going to zip through it for the purpose of this video, but you could spend a little bit more time than I am. Don't worry about the speed I'm going in, because I, excuse me, I knew what I was looking for. So 5 times 1 is equal to 5, and 5 plus 1 equals 6. So that's it factorized, which means that x equals -5 or x equals -1. And just to keep it on the one slide, I'm just going to grab a bit of room from over here. So step 3 is to sketch it, and all you really need to do is just draw the x-axis, draw a -5 in and a -1, and then you can put the y-axis in like that. Not that it matters, and it doesn't matter how the turning point goes. You're just looking at the shape. And here's the trick. This axis here is the y-axis. It is the values of x squared plus 6x plus 5. That's what these values are here. We want to know when x squared plus 6x plus 5 is less than 0. So we want to look down here. When is the graph less than 0? And it is less than 0 here, and it is less than 0 here. And that means that any x value below -5 or any x value above -1 will return a negative value for y. So if I just sort of extended that line as it continues down there, and I pick this value, which is maybe a third or something like that, -1/3, when I go down, I'll hit the y value. But if I go for a value in the middle here, then the corresponding y value is positive. So that's not good, and that's good. At these points here, I'll just change color again, sorry. At these points, y is equal to 0. In other words, x squared plus 6x plus 5 is equal to 0, but I'm only interested in less than 0. So that means that I've got two scenarios. So this is the solution. So I'm looking at the graph and I'm saying, well, the solutions are when x is less than -5, the function is less than 0, or when x is greater than -1, it is also the function y is also less than 0. And so this becomes our solution set. It is effectively the solution, the answer to the question. Any value of x that's less than -5, any value of x that's greater than -1. Just a couple more examples just to sort of tide us over, and then I'll finish up. Here, on slide 17 here, I've got -x squared plus 3x minus 2. So first things first, if I look at step 1, it's what is the concavity? We've got for y equals -x squared plus 3x plus 1, sorry, minus 2. We look at the value of a, or if you like, the sign of x squared. It's negative, so therefore it is frowning. Okay, so it is concave down. So that's step 1 done. Step 2 is the solution, and we set the equation equal to 0 and solve. So I have to solve -x squared plus 3x minus 2 equals 0 to get our zeros. Now, a hot tip here is that if the leading term, which is the highest power term here, so x squared, if the leading term is negative, we can take the negative out to make it a bit easier for ourselves. So it'll give me x squared, and then just flip the sign of everything inside. So we've got negative x squared minus 3x plus 2. Now, again, just to save time, I'm going to go straight to the factorization, but you can pause the video and try and do it yourself if you like. It's x minus 2, x minus 1 is equal to 0. So minus 2 times minus 1 is positive 2, minus 2 plus minus 1 is negative 3. And that means, now, that doesn't change the zeros. If there was a number here, it would, but just a negative by itself doesn't change the zeros. So we can look at each of the factors and use the null factor law. Therefore, x equals 2, that's from the first factor, and x equals 1. And then we can do, I'm just going to put the reasoning here, null factor law. So this is what you can do after you're practiced enough with using the null factor law. Rather than setting each spot equal to 0 and then solving, just go straight to the solution. That's all good. Okay, so that's number 1 and number 2 done. I'll just go into slide 19 just to keep it. It's good to give myself a bit of room, really. So we've got the zeros and we've got the shape of it. So now we can go to the graph itself. And I won't start with it. I'll just start with the x-axis, really. And I've got value x equals 1 and x equals 2. So I pop a 1 here and then pop a 2 here, and that means the y-axis is about there. And I draw my graph like so. Again, it doesn't really matter. I'm not interested in the turning point. I'm just interested in the shape. Because then I can have a look at it and go, well, I've been asked to find out when this whole expression is greater than or equal to 0, and that whole expression is y, and that means that on this graph here, y is positive up here. And if this line traces all possible values for y, then it's this part of the graph that I'm interested in. Okay, so I end up with shading in this as all possible values when y is greater than or equal to 0. Now in this case, because it's greater than or equal to 0, then I have to include those 2 dot points as well. And so for step 4, I've got if x is greater than or equal to 1, or x is less than or equal to 2, then the expression is greater than or equal to 0. So that's all good, and we could leave it there and that's fine. But a little bit of notation, when the values of x are between 2 points like they are here, as opposed to the other example when they were on the outsides, when they're between 2 points, you can have a bit of an abbreviated notation by saying, here's x is greater than or equal to 1, so you put the lower boundary on the left, and less than or equal to 2, so you put the upper boundary on the right. And that's just a nice, neat, tidy way of saying exactly the same thing as above. Okay, last example for this video. I've got 2 minus x and x plus 1. So it's already been factorized, which is handy. But what is a bit obscure is whether it's the concavity of it. But it's not too hard to work out. So step 1 is the concavity. If I just look, I don't have to expand the whole thing. If I just look at the x times the x term here, I'll have negative x times x, which is negative x squared. And so I can just say for step 1, it's going to be concave down. Okay, so it's a frowny graph. Step 2 is to work out the zeros. And so if I look at the first factor here, it's 2 minus x. So I'd add x to both sides to get x equals 2. I might just write that one down because it's unusual. So I'm adding the variable instead of a number to get 2 equals x. And then for x plus 1, I would get x equals negative 1. So there's my 2 possible values, x equals 2 and x equals negative 1. Step 3 is the graph. So again, put the x-axis in. I've got a negative 1. I've got a positive 2. Pop the y-axis in just for the sake of it. Doesn't really matter though. It doesn't matter where the turning point goes for the sake of this inequality. I just draw it in like so. And then I look at the question again. It says, when is it less than 0? And so I need to look at again down here and down here. That's when y is less than 0 or the expression is less than 0. And so that means that in terms of what are the valid solutions for x, it'll be down here and down here, which means that the final answer is going to be x less than negative 1 or x greater than 2. And there's no simple way of having a bit of a summary of that other than just writing it like that. There are sort of complicated ways of writing it as a single line, but it's not worth it. Okay, this video is long enough as it is, so I'm going to leave it there, and you can have a go at doing some inequalities yourself, and I'll see you in the next video.